Okay, that lets me know. All right. So, welcome back and happy Tuesday. Today, what my goal is to give you a little bit of background in some of the stuff that makes things like Copilot and ChatGPT work. Now, I can't go into all of the details, but I want to give you a sense of, it's not magic, right? It's just a little bit of math to really illustrate this idea, that this thing can go wrong. And so, in spite of using large language models or generative AI for doing work, it's really up to you to quote, as they say in the military, trust but verify, right? Because at the end of the day, you're responsible for the work that you put out. You can't say what was the chat GPT who did this. And so administratively, you'll notice on Canvas, I've extended the due date, right? Another week. And the reason for that was there's a bunch of stuff that I just did not know, right? So I apologize for that. I'm going to be learning some stuff from you. I didn't know, well, I kind of knew, but didn't know that your registration would take past the first day like it did and getting you on Canvas and stuff like that. So I really want to create an environment for success for all of you. And so I thought it best to extend the due date because I'd rather have you complete the assignment and learn from it as you move through the remainder of the time that we have together. And so the plan for today is to spend, and I've totally, I was up all night, a couple nights rearranging it, rearranged the whole course. And what I'd like to do is spend about the first 20, 30 minutes or so on technology, right? To support all the tools that you're going to use, followed by the formal material itself, no more than 45 minutes or so. And then after that, spend that last part 1 to 2 hours because I realize some have transportation to catch actually working on stuff, right? To give you this opportunity here to complete stuff and to work on stuff. Okay? All right. Any questions? No? So we're going to look at Canvas and specifically the homework submission. Slack, you all should have received an email invite to quote unquote join Slack, and I'll do a little tour of Slack, and then access to Copilot, which has a little bit of issues, and I'll explain what those issues are. And there's a workaround. I went to Campus IT, Information Technology Group, and said, wait a minute. As long as you have a Clark login, you're supposed to have access to Copilot. What's going on? And so for the student access, I didn't know that. It's different from the faculty staff access. And so there's a workaround that I have verified with my other class that I teach. So students are able to access that. So I'm going to pop out of the slides, stop the share, and I'm going to share my screen. And we're going to take a walkthrough of various things. So let me not show the dad jokes so you don't see the answer. All right. Um, and share desktop. Let me put my phone on do not disturb. I always get, those scam calls, the fake calls. People say, "Hey, this is, the IRS, blah 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 blah." Right? I always get those only when I teach for some strange reason. Okay, so let's go on to Canvas. Oops. And this is Canvas. So let me go to courses. Um, Please help yourself. Fundamentals of AI. And Canvas is a learning management system. I'm a heavy user of Canvas and online and digital tools because it helps me in being more efficient, but it also allows people, if you have an internet connection, to do things 24/7. And so I have a page here where you can look at some background information if you choose to. I also post the slides in PDF format. And so, for example, if you click on lecture two, there are different versions of the slide. One slide per page, two slides per page, three slides per page. Some people like things compact. Um, and then I have a course resources section where I link things like videos and documents. But then I also have the assignments as well. And so if you click on the assignment, let me see if I can go to student view, view as a student. if you go to the assignment one, personal branding, um, it's due March 23rd at 11:59 uh, and 59 seconds. But you'll see it's March 24th at 12:01 a.m. And why is it 12:01 a.m. the next day? Because Canvas doesn't allow you to say 11:59. So that's why. So you get an extra minute for that reason. But please remember that it is not 11:59 March 24th. It's 11:59, 59 seconds. So basically midnight on March 23rd. So please keep that in mind. So as a student, if you go into log into Canvas and you click on the assignment, um, it will give you the document that defines the assignment, the same thing that I printed out and distributed. But then if you click Start Assignment, it'll prompt you to go ahead and upload the file. So you click this box here, and it'll go to your disk on your computer, and you select something, it'll input it to Canvas, and then you hit submit, and it's submitted. And so it's set up to allow you to submit things electronically. Any questions? No. And so the other reason for it is there's something called gradebook on Canvas, right? And so when things are submitted and they're graded, I can enter those grades. And if you click on gradebook inside of Canvas, you always know anytime during the time how you're doing, right? So students will ask me all the time, oh, how am I doing? Well, it's in gradebook and it's exactly how you're doing. Okay. All right. Any questions? No? All right. Yes. Could you say your name again? I'm sorry. Clarence. Clarence. Yes, Clarence. Mm. That's a great question. As soon as I can get it done. Sometimes it's over the weekend. Sometimes it's another week. I try really hard. It's a relatively small class. Um, I try really hard to get it done. Like if something's due, well, by the next class, right? Typically over the weekend. Now, my other class have 41 students, right? So you can imagine an assignment with 5 questions. That's 5 times 41. That's a lot of stuff to grade, but that might take a little bit longer. Did I answer your question? Okay. And one more time, I'm sorry, Clarence. And you know what I do? Usually for my classes, I can log in and see the roster who's in the class and the photo that you associate with your ID. I like to sit there and stare at it so I remember name. I remember everything you told me and forget your name. So please forgive me if I forget your name, but remember where you went on vacation, what your favorite food is, and all that stuff. It's just a weird thing for me. All right. Any other question? No? All right. So I'm going to leave that view and let's take the opportunity to look at the instructions that I've curated accessing Microsoft Copilot. Does everyone have their login, like their email and remember your password? Now I know, you're not supposed to write down passwords, but sometimes people do, right? But anyways, no, Clarence. Uh-huh. That's a great idea. Hmm. Hmm. That's a great idea. That's a great idea. It's it's hard because you can easily have like 30 to 100 passwords depending on, what you're doing. They make some devices called password lockers, and some of them are in your browser, and some of them are an actual token that you carry around and you can plug into your computer and it'll inject the password for you. But um, you know, sometimes paper works well too. But nonetheless, if we look at the section called technology tips, accessing Microsoft Copilot, I've gone through and created a guide of sorts for accessing Microsoft Copilot. Now, one of the issues is that this first version of instructions might not work using student accounts. So the workaround that I got from Campus IT is down below. If you're unable to log in and get an error message that the student account is not supported, then do the following. And so what you're going to do is you're going to sign in to u.clarku.edu, right? And once you sign into that, you'll see a section. Let me sign in here. Here's u.clarku.edu, and you'll see a section called Email Microsoft, right? So you click Email Microsoft, and it will bring up your Microsoft email, Outlook 365, it's called. And once you bring that up, it'll look like your email. I'm not showing you the full email because, you know, there are federal laws about educational privacy, and students send me things about their personal situations, so I don't have that up on the screen. Um, but this is a cutaway of what part of my email interface looks like. Mela? This is u.clarku.edu. So it's HTTPS. And then when you're on the page, you'll see something like this. And then you click email, email Microsoft. Everybody there? I'll give you a minute or so. All right. So once you click that email, it'll bring up your email and you'll see part of the screen looks like this. This symbol, the third one from the top, that looks kind of like a colorful ribbon, that's the symbol for Copilot. If you click on that, it'll bring you right into Microsoft Copilot. And you'll see the chat window for Microsoft Copilot. So let's take a couple minutes to try that out. Yes. Ah, so this is sort of like a side door to get into Copilot because the main instructions that where you go to copilot.microsoft.com, for some reason with the student accounts, it's not working. And so I contacted information technology for the university because every Clark account, whether you're a teacher or a student, is supposed to have access to Copilot. And so this will work for students. It's the same Copilot, but for some reason, um, the other way doesn't work for student accounts. And so by first going into your email, and the email is just one program among a set of programs called Office 365. And so there's a program for making presentations, for drawing diagrams, for doing email, and for also Copilot. And so by accessing it through this icon in your Outlook account, it gets you into that with the student account. I don't know the reason why the other way directly on copilot.microsoft.com doesn't work for students. It's the same, literally the same program. To answer your question? Yeah, okay. Any other questions? How's everybody doing? Good. And once you're in Copilot, try it out a little bit. All right. So let's see. So that's Copilot. We talked about homework on Canvas. We talked about Copilot. We talked about Canvas itself. Um, and when you submit something, I can't show you what my side is because, it's there's other information in there. But when you submit something, I click on an interface and I see all the student submissions and I can click on each submission. It brings it up. It has a chat window. I can type in feedback and stuff like that and enter scores. It just helps tremendously in managing things so that you don't have big stacks of paper that you can lose that you're carrying around and such. Okay. Any questions? Everyone still there? Kind of settling in? Yeah. All right. So let's see. We talked about Copilot. Let's look at Canvas. Now, Canvas, and this is Canvas, and the link for Canvas, you should have gotten an email invitation to join Canvas. I'm sorry, Slack, to join Slack. And what Slack is, it's a messaging platform. And this messaging platform is self-contained. And you create these messaging platform instances, and then you can invite people to join. And so the reason why, excuse me, I'm sorry. The reason why I use Slack is because email is not very efficient. I literally get over 100 emails a day. And so, because of that, if you send me an email, as hard as I try, there's a very high chance that I'm going to miss your email. And it's not something that I plan. It's just that when you have 100 plus a day, that's like 800, 700 a week. And it's really easy to miss things. And so, what I like to do is for all of my classes, this class included, I create one of these Slack messaging systems, invite people to join, and that allows us to more efficiently have conversations with one another. And so the way of interacting is a so-called Slack channel. And inside of this Slack site, so-called workspace, I have a Slack channel called Fundamentals of AI. And each one of you is joined to it as a member, and that membership is created by responding to that invite. And what excuse me, it's been a long day today. I usually get to work at 7:30 in the morning. And what that invite will require you to do is to register with a username and password. That username should be your Clark email, but your password should be different from your Clark password because it's a completely different system. And what it does then is it includes you as a member of this Slack channel. So now I can message everybody and you can message me. So if you have a question about the class, you would log into Slack on the Slack channel and I can address the class channel, hello, send, and you all see that message. Now, I have Slack running on my phone. I can run it on the laptop, and it allows me to separate those messages. That's all that noise coming into my email and have it separate just for the class. And what it also allows me to do is so-called force multiply. If someone asks me a question about a concept in the class, about homeworks or what have you, others can see that interaction and benefit from that. So it allows me to kind of multiply my effort, and you'll see this history of these conversations going back and forth. Okay. Also, what you can do, let me choose one person, Sai, and you can click here to direct messages, and you can send a message directly to somebody. You select their username, and now when you type, you're sending it only to that person, but not to the entire class. In addition, inside of the channel, if I wanted to send something to Nelson or message specifically for Nelson that the whole class sees, I say at symbol Nelson, and then I say, um, this is a test, and everyone on the channel sees it, but it notifies Nelson that I've sent him a message. Does that make sense? And so it's much more efficient than email. And you can imagine in a class of our size or a class of 41 people or a big group or even a little group, rather than quote unquote polluting all of your communication with all these hundreds of emails that go back and forth, you're keeping it separate just among the members of the class. So it's a lot more efficient. Any questions? No questions? It's not linked to the private email. That's a great question. And in fact, you wouldn't want it to be linked to the private email because the private email, you're getting all sorts of messages about all sorts of things. And one of the things that Slack does, it says, okay, I want to have this messaging, but I want to have the ability to create these topic areas like fundamentals of AI. So anything about this course, you keep in this area. You could create another quote unquote channel about cooking tips or barbecue. I like to barbecue. And keep that conversation just on that topic. So to answer your question, it's not linked to your email. You can have Slack send you notifications to your email to say somebody's sending you a message, but it's not linked to your email. And in fact, there's an add-on. I don't have that add-on to Slack where it uses AI, and you can ask the AI, give me a summary of this conversation, right? which is a very useful thing. So it doesn't link to your email. It completely is self-contained, and you can slice it up in different ways to say, here's a topic, and all the conversation on this topic is separated from that. So that way you don't get the same issues you have with email. Have you ever looked at your email and you have like 100 messages, right? You can't, over time, you can't possibly read through all those messages. Some of them you might not care about. Hey, there's t-shirts on sale at Walmart, right? Well, you might get hundreds of emails, but when you separate it out like this and have this idea of topics, or in Slack, as they call it, Slack channels, it allows you to better manage all of this information. And so Slack is used in large organizations, it's used in medium-sized organizations, and I personally use it for my classes because it helps me to better manage all the interactions, and it helps me to be more responsive, right? If it's late at night or I'm going somewhere, I'm at the supermarket in line, my phone beeps, so and so has a question about the homework. Oh, okay, I can answer that. And I can do that anywhere I am. Okay? To answer your question, hey, good evening. How are you? Oh, please have a seat. Grab some food. Any questions? Is everyone? I see a couple more people are on Slack. Thank you. Um, and so what I'll ask you is, and I'll post a link to it on Canvas, to the Slack channel. If you have a question, I would prefer, I'll still see the emails if you send me an email, but keep in mind that depending on the hundreds of emails that I get, it might get buried and it takes me longer to respond. But if you use the Slack channel to ask your question, um, I'll respond much, much quicker, like within an hour or two, usually. Okay? All right. Any questions? No questions? No? All right. So that's kind of our tour. Um, we're making good time. So let me remind myself what I was supposed to be doing. We said the tour for Slack, the tour for Canvas, and signing into Copilot. So I think we've checked off all that stuff. Okay. So let me stop the share and let me go back. Let me minimize that. And I'm gonna get back the slides. Oops, let me kind of put that down. Don't want you to see the punchline of the joke. Share. All right. So we're back. So um, we're gonna look at concepts of probability. Okay, banner view. All right, check. I'm on, recording. All right, good. So, any last questions about that stuff? No? Going once? Yes. Jen? Uh-huh. Uh-huh. Hmm. When you go to I see. Microsoft Network. Yeah. Mm-hmm. Mm-hmm. Yeah. A lot of these internet search engines, Google has Gemini, Microsoft has Copilot, which is really ChatGPT. They started integrating it into their web search. And so it'll give you some Copilot answers, but it's not the full Copilot. It only is web search. And so you want to log into actual Copilot to get the full experience of all the features of Copilot. Yes. And then click on the Copilot icon. Because I don't know what parts of Copilot they're using for MSN and the browsers, but I know it's full Copilot when you go in through the Clark email. Okay. All right. Any other questions? Yes. Mario. Yes. Okay. You have a question? And what's your name? Okay. Hector. Okay. Hector. Yes.
To this Clark College thing.
Oh. Oh, it's Clark. Huh?
So I'll show you. You go to Canvas.
Canvas.
He uses his Clark credentials. So
Hmm.
do your Clark credential again.
All right.
Click
Can we
on
have a? Hmm. Yeah. Oh, that's weird.
Yeah.
Because Clark College isn't Clark University. That's weird. When he logs in, it's forwarding him to Clark College and not to Clark University's landing page. Okay. This is just what is due and sort of the administrative stuff for the day. We haven't gone into the material yet. Okay. Yes. So I'm just showing people around Canvas and how to submit homework. If you click on the homework assignment, it'll prompt you to select a file that you want to load onto Canvas, and that's how you submit things. Okay. Yes. Hmm. Okay. Okay. I've extended it a week to give you more time, and then we'll have about an hour, hour and a half today for people to work on stuff. Here. Yes. 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 I know. Oh yeah, yeah. About Copilot? Okay. Okay. Um, it does well, the school already purchases what's called an enterprise license. So they pay a bunch of money to Microsoft to be able to use Outlook 365, and Copilot is included in that. It won't ask you to subscribe. You go through the Clark email, right? Um, and then you click on the Copilot icon and you don't pay anything. It won't ask you to subscribe because Clark has already paid for it. Any other questions? No? All right. Okay. Excuse me. My voice might all right, so I have another one. So the dad joke of the night. Um, did you know that French fries, the original French fries, they weren't cooked in France? So if they weren't cooked in France, where were the French fries cooked? What's your thoughts on that? Where were French fries cooked? The original French fries, if not in France. You already know. You've seen this one. You haven't seen this one? All right. Where do you think they were cooked? Sorry? Oil? Oil? Yes, you got it. They were cooked in grease. All right. All right. Anyways. Yes, they were cooked in grease. All right. Okay. So I don't have my remote today, so I'm gonna kind of run back here and click these slides. All right. So there are many scenarios where there are options or choices. You could take choice A or choice B. Or when you look at something happen, you can have many different things happen. And so the whole reason for this tool called probability, which is how things like ChatGPT and Gemini work, is because of probability in action. And so my purpose today is to spend about 30 to 45 minutes or so teaching you a little bit of the basics of probability. And the one thing I'd like you to remember is, oh, this thing can be wrong. There's absolutely no magic about what underlies these large language models. So, one example, if you go out to the crosswalk, the main crosswalk of campus, I call it the crosswalk of doom, right? I learned you have to wait and actually see the car stop before you walk across the crosswalk, or else you take your life into your hands because they don't play around going on Main South, coming by Clark. Um, but one question I have for you to consider, how do you describe, if you're standing in front of that crosswalk, things that you see? You see a person walk by. How many people walk by? Is it the same every moment in time? How do things move? Is it the same moment in time? Do things move the same way? No. So if you were trying to make a computer decide what to do as a result of seeing a car, well, how do you move? Where do you go? How do you go? Because at the end of the day, the things that you're observing, that you're seeing, they can have many different outcomes. So, how do you manage all of that? That's what probability is for. And so, this idea is something called uncertainty. You have to be able to measure this uncertainty. This thing is more uncertain than that thing, but we haven't defined yet what uncertainty means. You have to be able to quantify uncertainty. You have to be able to describe it. Quantification is the description of. And then once you can measure it and you can describe it, now you can make decisions. This thing is bigger than that thing. These two things are equal. And based on those types of comparisons, you can now make decisions, even though it's uncertain. And at the end of the day, you don't really know for sure what's exactly is going to happen. And so, what exactly is uncertainty? It's a condition where the outcome or the result or what you see can't be completely determined. One moment, Mario, ah, guess what one of the big drivers of probability was? Gambling. Gambling. Yes. Believe it or not, gambling. Games of chance were a big driver of probability because they wanted to be able to measure it, to represent it, and to be able to decide what's best to do, right? But it's not just gambling. Have you ever seen these self-driving cars, right? There's a lot of uncertainty in driving. And those same principles that are used for gambling are also used for self-driving cars, right? So absolutely beautiful framework. And you can't, therefore, for sure, be so sure about what's going to happen because there are many ways you can get it wrong. You can make errors, right? Okay. Some examples, like you alluded to. You roll a die, you flip a coin, you pick a lottery number. There's a lot of uncertainty wrapped up in that. What about customers walking into the store, into a store, or people walking across the street, across the crosswalk of doom, I call it, right? Um, what about the temperature? That temperature changes from one instant to the next. Well, I thought you said it was going to be 54 degrees. It was weird. Late at night last night, it was really warm. That was just odd. It was like being in Caribbean. Or who's going to win the game? This who's going to win the game? If you've ever heard of like FanDuel and DraftKings, there's a lot of monetization wrapped up in these probabilities. You have the pass percentage, the pass completion, all these things. And people run these simulations and they use it to try to decide. But there's a lot wrapped up in using uncertainty. And so this example I wanted to show to you, there's no sound to it. And this is an instrumentation for customers walking into the store. Now, inside of the store, you have this thing, and this video is going to get bigger. Let me make it a little bit bigger further on. You have what's called the entry box of a store. You know, you walk in and go, can I help you? No, I just want to look around. And there's some cameras overhead, and you'll see these green boxes. It's tracking the people that go from outside the entry box through the entry box to the inside of the store, and vice versa from inside the store through the entry box to outside. I'll direct your attention to the upper right-hand corner. It's counting the number of heads that go into the store, number of people, and the number of people that leave the store. If you subtract the bottom number from the top number, that's the number of people in the store. And so this means at every minute, every second, you can calculate, measure how many people are in the store. Now, if your cash register is computerized, now you can compute something that says how much average dollars or revenue do I get from each customer at 8 o'clock in the morning, 9 o'clock in the morning, and so forth. And so this idea of uncertainty is the number of customers going into the store. Is that always 9 people per minute? No. You don't know what it is. It's going to change. But by measuring it and representing it, now you can make decisions about it. So let's unpack some of these decisions. How many customers visit the shop and when? Well, why would you want to know that? How many coffee beans should I buy next week? Because if you're a coffee shop and you don't know how many customers are coming in to buy coffee, you might buy too many beans, and beans are perishable and they spoil. And now you've just wasted your money and heaven forbid might go out of business. Now, if you know how many customers are in the store and you know how much revenue is being collected during a period of time, you need to know, can I afford to hire 10 employees during that shift or 5 employees during that shift? Because the surest way to go out of business, the largest expense for any business is the employee cost. So if you get it wrong for hiring too many employees, well, you're not going to be very profitable. How long will the drive-in line get? Right? That's a good one because the people arriving at the drive-in line, if it gets too long and it's not going fast enough, they're going to drive away and you lose that sale. Unless you're Chick-fil-A. You know what Chick-fil-A does? They're smart. They have people walking around with these mobile devices and they take your order and swipe your card there, even if you're at the end of the line. So they got your money. You could leave if you want to. They've already got your money, right? And so you're committed now. You're going to stay there. Damn it. Right? You're going to stay there. So that's pretty smart by Chick-fil-A. So how they do that and say, okay, well, I'm going to have an extra person or two walk in the line with this mobile scan device, right? And that's all based on measurements. How many food items will I sell, right? They track all this stuff. All of these things are uncertain. You can't say it's 12 per minute, it's 10 per minute. It might be 20 per minute. It might be less, it might be more. That's what uncertainty is. So we still need to make decisions about it because if you just kind of go by seat of the pants, you get it wrong, and that's the quickest way to go out of business. So we need some tools, and that tool is probability, and large language models use that probability, and we'll expand on that more specifically, some of those technologies next week. But we need tools for probability. You can't look at large language models without looking at probability. And so I showed you this picture last time when we talked about some computations, some programs running are so big, you have to scatter pieces of it across hundreds of thousands of computers. And a large language model, something like Copilot, is not only over hundreds of thousands, it's over several millions of computers. It's that big. And so all of these things coordinate to answer a query. And what it's looking at is the probability that one word will follow another. That's all it's doing. Okay. Any questions? No? All right. So here, if you typed in complete the question. Hmm. Hmm. Yes. In the future, I don't know how soon that feature is or how far away it is, but quantum computing is a complete replacement of how we compute things now. And it uses a lot of concept from physics that's honestly not in my area of research. But at that point in time, something the size of your laptop that you're using will look and laugh and say, ha, imagine that used to take a whole building with hundreds of thousands of computers. Kind of like history repeating itself. But absolutely, once quantum computing is a reality, right now it's in the research lab. It's not an actual product that you can go out and buy. But like what happened with the computers we have now, you know, 30, 40 years ago, what you had on your desk in front of you, or even a phone in your hand, would fill buildings probably like 20 to 40 times the size of this one. So, yes, absolutely. Any other questions? No? All right. And so if you went into a large language model like ChatGPT in the very early versions, you'd type a sentence and it would complete it for you. You would say, fix this story or tell me a story, and it generates this text. And what it's doing is it's inputting tens of trillions of documents from over the web and it's computing a lot of probabilities. And these probabilities look at all the different ways that words can follow one another or precede one another. And that's all it's doing. So when you give it a query and say, um, tell me about this thing, it sees this phrase that you type and it's looking that up in its many, many deep records of different ways that words follow one another. It's selecting the highest probability, explain what probability means, and then just typing it out on the screen. And that's all. And so one of the things to keep in mind is that large language models can so-called hallucinate. They can make up something that sounds so good, but if you actually look at it and read it, it's gibberish, right? So it's really important to know that this is not magic, and you have to verify what it's doing. Okay? All right. Any questions? No questions? No? All right. And so let's take a look at this uncertainty. And so we alluded to this idea that you have different outcomes that can happen. If you have different outcomes, you have to describe what you see. You describe those outcomes. Okay. So let me ask a question to you, and let's just be casual. You're among friends. If I said, what is an event? What do you think? Like, what would you say? Share your thoughts. What is an event? Or any definition of the word event that you might think of. A performance, a gathering. Okay. Something you have to plan. So it's something specifically that happens. And it's not so much what happens, it's that it happens. It starts now, and maybe there's a DJ, or maybe it's like a barbecue table, or maybe there are some, there's an act that performs or something like that. All right. So let's imagine now. Flip the coin. Who wants to flip a coin? Let's have, who said, flip a coin? Oh, okay. Let's flip a coin. You flip it right on onto the floor. No, we're not betting. Yeah, it's not worth anything. So what happened? Tails. Okay. So how did you know it was tails? You saw it. You had to observe it. You saw it. And you saw it. Okay. And you wrote it down in your brain. It's a tails. Okay. Observation is a necessary um, ingredient for the measurement of an event. The event is the thing that you do, the thing that happens, but the observation is the result of looking and writing down what you saw happen. So, not a trick question. What did you see? Tails. Okay. All right. You saw tails. This event happened and you saw something and you wrote it down. Will it always be tails? So, prove me wrong. Let's have someone else flip it. Oh, man. Oh, all right. All right. So, let's try again. All right, so let's try one more time. Third time works like a charm. Okay. All right, there we go. Heads. Okay. It came out heads. So is it always the case you see tails? Is it always the case you see heads? So we have a problem here. We have no idea what's going to happen to this coin. Let me ask you a related question. We saw that happen. How did you do that? That's awesome. Can this one happen? We saw it happen. Okay. So it's not the same every time. So how do you describe something if you have no idea what it's going to be? We need a system for doing that. Okay. So it's not the same, or could be. Sometimes when I do this explanation, it turns out tails both times. Like, yes, okay, good. That's how they work. But no, it's not. So we need a little bit of machinery. So if it's not the same each time, let me ask you, how do you describe it then if it's not the same? Let me hear your intuition. Don't be afraid to put yourself out there, Jen. Mm, now you're using some loaded terminology. You're right. Uh-huh. But how do you describe it? You said 50-50. 50-50 what? Probability. But just let's focus on what you see. Dimensions, that's involved in probabilities. But let's take a step back and be more simple. You said you saw tails, and then what else did you see? You saw heads. So if you want to describe how this thing behaves, you need to write down everything that you can possibly see. Because at the end of the day, you have no idea what's going to happen. You know what's possible to happen. Okay. And you do that through observation. Let's consider a different event. How about rolling a die? All right. So we're going to roll a die. What did you see? That's pretty good. You saw a five. Okay. Now, is this thing, the die, different from that? How's it different? One has six. And what about the coin? In terms of what you see the die, you said six things. What about the coin? How many things there? Two. Well, three. Yes, I understand the three because that edge. Um, so two things. So let me ask you, if we were going to wager, now we're not, and I said, all right, I'm going to bet you $1. Which game would you rather play? The die or the coin? Why? Why the coin? The Oh, you just absolutely. So if you get it wrong and you said, I'm going to bet heads, how many ways can you get it wrong? So twice, but you pick one. So with the coin, if I picked heads, you flipped it, there's only one way I can get it wrong, right? With the die roll, if you picked five and you rolled it again, there are five ways you can get it wrong. So you have this visceral, this kind of in your bones idea that this die roll is quote unquote harder than the coin. And that's what probability does. It's what we call a calculus, it's a system of measuring and comparing things so that it can do exactly that. Say this thing is more difficult than that thing, right? And with that, you can use it at a course level for things like this word is more likely to be next versus that word, right? In a sequence of words. And so you have this idea of this difficulty, and probability formalizes this idea of difficulty so that you can make these comparisons and make these decisions at the end of the day based on these comparisons. Does that make sense? Any questions? No? Now, I didn't understand this in college. I had to go to grad school. I'm like, why the hell didn't they say this the first time, right? So, an event needs a bunch of things. Something has to happen. An experiment or trial, as it's called more formally. And then you also need observation. You examine the outcome of that experiment or trial. You roll the die. The observation was five came up. You flipped the coin. The observation, what you measured or saw, was the heads or the tails. And this last one, I always believe that you can have many answers to life's issues and problems from 80s R&B, right? Now, this last one, I don't know if anyone remembers Babyface. Yeah. So you want to know oops, oh no, when you can see my daughter's going to be upset. I'm joking. No, no, that's all right. So you're yearning to see that five come again. Come on, five, right? So you want to know for this observation, simply, when can I see you again? Right? So you need to measure that. Let's talk about some of those measures. Okay. And so in order to do that for an event, You need to count or enumerate all of the different things that you can observe. We saw for the coin, you said, all right, two things can happen. The heads can happen. I can observe that. I can observe the tails. For the die, I can observe the one, the two, the three, the four, the five, and the six. There are six of them. And so it's not always that easy to enumerate all of the possible observations. But nonetheless, we know that in order to talk about probability, this idea of difficulty, which you all understand already, you need to be able to count things, all the different outcomes that can happen. So you observe an outcome. It could be the side of a coin, it could be the side of a die, or it could be a particular word follows another word. If you read through a whole bunch of documents, sometimes it's dog jumped, sometimes it's dog barked, right? And if you do that for enough documents, tens of trillions of documents, that's a lot of documents, you can construct these probabilities and then use them to generate what sounds like language and it sounds like the machine understands. But all it is doing an accounting of these different probabilities and it's just choosing one that most closely matches what you typed in at the interface. Does that make sense? Hmm. 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 Yes. Hmm. 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 And in the earlier versions of ChatGPT, version 3, we're up to version 5 now. If you said an airplane crashed in the Himalayas, where did they bury the survivors? It would say all this stuff, right? Survivors don't get buried there. Survivors, right? And so it's gotten better, right? Because they've incorporated more information with more examples to do that. And so you observe an event and you don't know what outcome defines the observations for the experiment. So you have to write out all the things that are possible, a collection of outcomes. So the coin events, you said there's a heads and there's a tails. For the die event, you said it can be one, two, three, four, five, or six. Okay. And so mathematically, we need a way to write out collections or groups of things. And that mathematical thing is called a set. All they do is they put an open curly brace to say this is where the list of things begins and this is where the list of things end. I don't know why they use curly brace. I never studied that history. So for the coin events, we say we start with the heads and then we get a tails also. The die events, it's one through six. Does that make sense? Okay. Now, there's a term called sample space omega, and it's capital Greek letter omega. And you want to know why mathematicians use Greek letters? Because it looks fancy, right? There's no reason why they should. But nonetheless, the real reason is that it's not English. And so they want to use something that looks different from the things that they're describing, right? That's why. But it also looks fancy. And so what sample space omega does, it's designated for this listing of all of the possible outcomes that you can observe. And so here in this description, I have omega with a subscript coin, just to note visually that this particular list of observations has to do with a coin flip. Here, omega has a subscript die to just note visually that this particular collection of outcomes happens to be for a die roll. Does that make sense? Any questions? And so generally, a sample space has some number of events. I'll call the first one event E for event one, event two, event three, event four, event five, up to what I'm calling event N, and N could be any number. Could be 10, could be a million, could be 100. It doesn't matter what it is. But generally, I assign a number to each event, and that number starting from one, going up by one each time, will tell me how many things I have in that collection. So if I were to look at the coin flip, I have two things, event one and event two. For the die roll, I have six things, event one, two, three, four, five, and six. Does that make sense? All right. So now, what in the world is this? let's make this a little bit more complex, and we'll just sort of reason through counting different events. So if I want to measure the size of this collection, I use these vertical bars called the magnitude or the cardinality. It just answers the question when I list it out, how many numbers do I have? In this case, I have n. In the coin case, I have two. In the die case, I have six. And what they often do mathematically is they want to be very compact. They don't want things to be, occupying large amounts of the page. They want it to be very, very tiny in the page because you're going to want to write a lot of this stuff. So one of the questions is, how many events do I have in the set of some number n many rolls of a die? Well, just like we said before, you have an experiment, you roll the die, you have an observation, you measure what you see. So if we had n equals 2, that's the roll of two die. That's much more events than just the roll of a single die. So let's walk you through how to count or enumerate all of these things. So you have the first roll here. It's going to have some number of outcomes. The second roll, the third roll, the fourth roll, etc. So you roll the die. Now you're going to do that for each position, and we ask ourselves, what are the observations? So for the first roll, how many different observations can I have? Six. Okay. What about for the second roll? How many observations can I have? Six. Okay. So with that, for each roll, roll number one, I can have a one or a two or a three or a four or a five or a six, six things. Roll number two, same deal. Roll number three, same deal. So I have six choices, six possible observations for each one of those rolls. Rolling two die is the same problem as rolling the die once and rolling a single die another time. It's the same problem, right? So here, when we have all those choices, we multiply them together. And the reason why we multiply them together, if this is a one, this can be a one, two, three, four, five, six. If this is a two, this can be a one, two, three, four, five, six. If this is a three, this can be a one, two, three, four, five, six. So for every choice of this one, you have each choice of that one. So you multiply, right? Now, if I had three die, that would be six choices times six choices times six choices. And as you can imagine, this gets very big in terms of the count very, very fast. So arbitrarily, if we roll n die, that's six times six times six times six n many times, or six to the n power exponent. Does that make sense? So this gets really, really big. So if you're going to gamble on the roll of two die versus the roll of 10 die, it's a lot easier for the two die than the 10 die. And the reason for that is that the 10 die is six times six times six choices 10 times, right? That's really, really big. So if that's the case, you only get one guess. This is going to be one, this is going to be two, this is going to be one, this is going to be four, this is going to be six. Out of that one choice, well, you subtract one from six to the 10, six times six times six, 10 times versus 36, which is six times six, subtract one. There are many more ways to get it wrong if you're rolling more die. But you need to calculate that. And that calculation gives you the tool to be able to compare and contrast these two different systems to do things like this one is more difficult, this one is easier, so you can make an informed choice. Does that make sense? Any questions? No? Mm-hmm. 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 Yes. Okay. Ah, so then you would expand your system. You now have a new observation, and the first time that observation comes up, now you have a third choice called the side, right? You could start from the beginning and do a careful study or analysis of your system and say, I know there's a heads, I know there's a tails, it could land on the side. But let me ask you this question. Is the side gonna come up more as an observation, more or less than the heads and the tails? What do you think? What are your thoughts? Less. Yes. And so absolutely in probability, you can, in your enumeration, you can include things even if they don't happen very often. Absolutely. Okay. Any questions? No? That makes sense? All right. So the first definition, you do something, you observe an outcome. And so you need to express the proportion or the fraction representing how often you're going to see this thing again. For the die roll, you have one outcome out of a total possible six outcomes. For the coin flip, you have one outcome over a total possible number two outcomes. And so you always express it per centum from the Latin by the hundred as a percentage. And that's the definition of your probability. So if this proportion is higher, when can I see you again? It means you're going to see it more often. If that proportion, that percentage is smaller, you're going to see it less often. So in the case of the coin flip, it's 50%, one over two for each alternative. And you could say, you know, maybe it's 49.99999% because you want to have a tiny bit of probability for that edge case. But until that edge cases happen, most of the time, you don't need to talk about it. You have what's called negligibly small probability. If that probability is like, you know, 0.00001%, it's so small, you might as well just call it zero. Okay. And but that's really up to you how realistic you want to make your representation, because you might spend a lot of time and energy representing things and measuring things at the end of the day you almost never see occur, although you saw it occur twice when when Jen flipped, right? That's awesome. Um, Yes. If in what your application is, if you don't need that observation, you can leave it out because it's so small in terms of how often it's going to happen, you almost never see it. But if you're dealing with, for example, a self-driving car, you probably want to spend the time and the energy to include these rare observations. A tree falling on the car, dog running out into the street. That doesn't happen that often. But if it's life safety involved in it, you want to spend the extra time and energy in representing the question. Yes, yes. Clarence. Yes, yes, that it won't work. And also, Lysol is trying to cover their butt, right? Because you buy Lysol and you disinfect an area and you still get sick, you're going to want to take Lysol to court. Well, you know, it's 99.99%. So nothing is completely foolproof. Nothing works perfectly. And absolutely that 99.9%, because it's not going to kill everything. But in addition, they have a legal staff that knows probabilities, and they say, you know what? Just in case this doesn't work, let's just have it 99.9%, not 100%. Okay. So with enough disinfectant, will you kill everything? Yeah, you could have enough disinfectant to fill a swimming pool, right? That's going to kill a lot of stuff, but they're still going to say 99.9%. Same thing if you buy like subscription to these places for running your website, right? Businesses need their website to make money. And so if that website goes down, the business doesn't make money. So that business could then go to the company that maintains the website, said, I'm going to take you to court because you've deprived me of my revenue, right? So they say, you know what? We only guarantee 99.99% of the time that this is going to work, because you always want to leave yourself that out because you never know what's going to happen. Websites go down, bacteria survive through the disinfectant? That's a great question. Right. Any other questions? No? So if you ever see anything that says it works 100%, don't believe it. Nothing is assured. Okay. And so, yes, Mm, yes. Hmm. 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 Yes. Hmm. Yes. Yes. Another consideration is that if you are representing every minute detail that could possibly happen, then your representation gets so big when you're trying to use it, it's not going to work very quickly or very well. So there's this trade-off in any sort of engineering design. How faithful is it to the real world? And can you compute it in a reasonable amount of time? And there's always that trade-off. If there's life safety involved, then you spend the resources to be able to represent all of those small details. Absolutely. Absolutely. Mhm. And then some companies look at what is the probability that this thing's going to happen, and they decide it's just cheaper to deal with it in court than to actually fix it because it's going to cost more. Some companies, like there was a case from decades ago where a car company didn't have a big enough firewall, like physical firewall for guarding against fires from the fuel tank. And they made a decision that the cheaper cost of not having a better firewall um, was better in dealing with the lawsuits. And what happened is that a car got into an accident. Have a great night. Got into an accident and it lit on fire and somebody died. And so some of them make the cold-blooded choice to say, I would rather deal with the lawsuits than to spend the money on the better design because it costs more for the better design. Um, and it's cheaper to deal with the lawsuits. It's crazy, but that's literally what happens. I don't know all that history, but hmm. Oh wow. Yeah. Oh man. Hmm. Well, yeah. Well, I remember when I was little on TV, they never used to advertise medications and drugs. Now you see it all over. And you'll notice at the end of the commercial, they're skipping through a field, they're dancing, doing all sorts of stuff. And then you have that voice might cause swelling, might cause this, might result in death, might be, yeah. So that's the one, that's the 0.01 from the 99.9, right? They're just kind of saying this something could go wrong, right? And so you always want to account for something going wrong because you don't know. Um, so when you have objects that you can observe, your sample space omega, um, there are two different ways of talking about probability. Sometimes these observations, no one observation is preferred over the other. With the die roll, unless you have loaded die, but with the die roll, they're all equally likely. That scenario of all the observations having the same probability is called being a random game, right? Um, the opposite of random is biased. And what biased means is that there's some preference, i.e., the probability for one of the observations is greater than the other observation. Now, if I put lead weights in this styrofoam closer to one edge, I'm biasing one of the sides, and its probability, well, it'll go down like that, and the opposite side is more likely to show, right? So if someone says, I say this, someone says, "Oh, I just had a random thought." No, you had a biased thought, right? Because your thoughts are not random. It's hard to, if you tried to speak random words, it's hard to do that. Language is not random. That's why these AI models work. because certain words follow other words and precede other words in a predictable way. And if you do it over enough documents, tens of trillions of documents, you can get pretty good in responding to just about any query that someone types in a window. And that's effectively how these things work. But if some words, and I'll get to your question in a sec, are less frequently occurring with one another, the AI model is not going to do that well, right? Your question is, yes, they do use AI models to screen resumes. Hmm. 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 Yes, yes. You should try an experiment. Hmm. Hmm. Yeah. You should try an experiment. Have a different name, same resume. Send both resumes to the same organization and see which one gets the call back. There was somebody who did that online, and the outcome was shocking. It was shocking. Yes. Hmm. 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 And you're allowed to have an alias. It's not just Jay-Z and and those folks. You can have an alias, but try it. Try it out. So I would recommend having different names. Hmm. 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 Yeah. Oh, I can only imagine. I can only imagine. Hmm. 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 Yeah. It's disappointing, but even more disappointing is that it happens a lot more than people think. And I'm sorry that happened. Yeah. Hmm. 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 Good. Good for you. Good. Yeah. Hmm. 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 And the scary part is that you're collaborating with your friend in doing that, but hmm. Hmm. Yeah. Hmm. Hmm. And unfortunately, to use a probabilistic term, there are biases. And whenever you have people, you're going to have some biases. But, I've also found that sometimes advocacy comes from some places you would not have expected, right? And I've experienced that personally, but I'm sorry that's happening. I would try having the same resume with the two different names and seeing which one gets the hit. But you can absolutely have an alias, right? Absolutely anyone can. Okay. Right. And so biased means that some are preferred over one another. And if you choose word sequences in an AI model that aren't very common, it's not going to do very well because it hasn't seen many examples, i.e., the probability is low for that particular word occurring before or after the word in question. Does that make sense? So, this idea of hallucination, it doesn't really know what the good solution is. So, it just picks one from whatever it has. It doesn't have a lot of examples recorded in its probabilities. And so, what do? The probability of a particular observation is just one divided by the size of this sample space, all of the possibilities, omega. And that's all. And so for the coin, we had 1/2. For the die roll, we had 1/6. And so that question of n many die rolls, right, where n is the number of die rolls, It's just 1/6 because there's six outcomes per slot, raised to the n power. So 6 times 6 times 6 n many times. If it's two die, it's 1/6 times 6. If it's three die, it's 1/6 times 6 times 6. So you can see that probability gets smaller and smaller and smaller with just a handful of die rolls. But now you have a framework for being able to talk about this thing is more difficult than that thing. And if you've ever been to a casino, you'll notice the wager is proportional to the difficulty of the game, right? Um, because if something's too easy, well, they need to pay out. And I promise you, the casino is always going to make money. They're not in business to lose money, right? Moreover, if you are pretty good in your mind of calculating probabilities, they're going to gently escort you out the building because they don't want someone who's advantaged. It's not cheating, it's just math, right? But nonetheless, they don't take too kindly to that kind of thing. All right. So I'm gonna, I don't know, let's see. Yeah, I'm gonna end there. I'm gonna end there because this is a good breaking point. It's 7:20. This is a good halfway point where we can just get bio break and stuff like that. And then we'll pick back up in about 10 minutes with just working on accessing Copilot and working on the work. The only thing I was going to do was just to visualize what I talked about, and we don't need to visualize it. Is this the same thing again? So I'd rather just have our schedule, take that breaking point, get a bio break, walk around, stretch your legs, get the blood flowing, and then we'll pick up the second half, just working on stuff in Copilot. Okay? All right. Awesome. Any last questions? No? Yes, sir. Hmm. Okay. Ah, yes, I extended it for another week. So you can then type it up and then upload it into Canvas. Okay. Any other questions? No? All right. So I'll stop the video and we'll end there and pick back up with just working on um, the assignment. Why did this record? Stop recording.